Hello friends, today I will discuss about parallel operation of transformers in a substation and impact of fault MVA in the LV side of bus for parallel operation of the transformer. Now why parallel operation of transformer is required in a substation? Number one is to meet the load demand in a substation. For example, we have one number of 10 MVA capacity of 33 by 11 kV transformer in a 33 by 11 kV substation. Now the 10 MVA transformer is sufficient to meet the load demand of that substation. But due to increase of the load, now the transformer capacity must be increases, or there are other option, that is installation of another transformer of 10 MVA or lower capacity. So to meet the load demand, parallel operation of the transformer is required. Number two is better reliability and switching operation. For example, number of transformer are running in parallel condition. That is, two number of 10 MVA transformer are running in parallel condition and total load is 10 MVA. Now, for one transformer is required for maintenance purpose, and due to maintenance purpose, we are switching off the one number of transformer. So it is the other transformer is sufficient to cater the load. So it is the switching flexibility is better in case of parallel operation of the transformer. Number three is uninterrupted power supply can be done due to outages of one number of transformer unit. Now, for instance, there are two or three number of transformer unit are running in parallel condition, and due to fault in any one of the transformer bay, the transformer will be in breakdown condition. For example, in the transformer bay, one number of CT or LA is burst. So the due to LA burst in the transformer bay, differential relay will operated, and due to this, the HV side breaker and LV side breaker will be tripped, and due to this transformer will be in outage condition. So other one number or two number of transformer is sufficient to cater the load, and thereby uninterrupted power supply can be possible due to outage of the one number of transformer unit. Now, what are the conditions that must be met for parallel operation of three-phase transformer? The number one is same voltage ratio for all tap position of the transformer. For example, we have two transformer 1 and transformer 2. The voltage ratio shall be same. That is, if HV side is 33 kV and LV side is 11 kV, then for transformer 2, the HV side and LV side voltage should be same. And again, for all tap position, the voltage ratio shall be same. Otherwise, due to mismatch of voltage in any other tap, there will be a circulating current will flow. Number two is same polarity. That is, the transformer which are connected in parallel condition must be connected with proper polarity. Otherwise, huge circulating current will flow for polarity mismatch in between phases of the two or three number of transformer. Number three is the vector group of the all the transformers shall be same. For example, we have a one number of YD1 transformer. Then we want to connect this transformer with another transformer in parallel condition. So the another transformer vector group shall be YD1. Again, if the vector group of the installed transformer is DY11, then the another transformer which is connected with the existing transformer in parallel condition must be of the vector group of DY11. But there are exceptions that DY11 and DY1 transformer can be parallel with some modified condition. That is, by changing the phase sequence of the transformer, we can connect the two separate vector group in parallel condition. Similarly, YD1 and YD11 can be parallel with modified connection. Number 4 is the same phase sequence. The phase sequence of all the transformer which are to be parallel must be same for same vector group of the transformer. Now, how does the load will be shared for parallel operation of the transformer in a substation? The load will be shared by the transformer in proportional to the kVA or MVA rating of the transformer and inversely proportional to the percentage impedance of the transformer. Now let us take an example, that is two number of transformer are running in parallel condition, and T1, that is transformer 1, MVA capacity is MVA1 and percentage impedance is Z1, and transformer 2 per MVA capacity is MVA2 and percentage impedance is Z2. Then the load shared by transformer 1, that is T1, will be equal to MVA by Z1 divided by MVA by Z1 plus MVA2 by Z2 into total load, that is the total MVA capacity of the substation. Similarly, load shared by the T2 will be equal to MVA2 by Z2 divided by MVA1 by Z1 plus MVA2 by Z2 into total capacity or total load of the substation, that is total MVA capacity. Now let us take an example, that is total load is MVA in MVA is 100 MVA and transformer 1 MVA capacity is 50 MVA with percentage impedance 12% and transformer 2 having MVA capacity 50 MVA and with percentage impedance is 12%. That is MVA and percentage impedance of the two number of transformer which are in parallel condition are same. So load shared by T1 will be equal to 50 by 12 divided by 50 by 12 plus 50 by 12 into 100, which comes as 50 MVA. Similarly, load shared by the T2 will be same. So if the MVA capacity and percentage impedance is same, then the two or three number of transformer running in parallel condition will share equal load in MVA or kVA capacity. Now let's consider the transformer 1 MVA capacity is 30 MVA and transformer 2 MVA capacity is 70 MVA with same percentage impedance. So load shared by the T1 is equal to 30 by 12 divided by 30 by 12 plus 70 by 12 into 100, which is equal to 30 MVA. Again, load shared by the T2 is equal to 70 MVA. So since the percentage impedance is same, the load shared will be the ratio of the MVA capacity of the respective transformer only. Now let us consider the T1, that is transformer 1 MVA capacity is 30 MVA and percentage impedance is 10%, and T2 MVA capacity is 70 and percentage impedance is 12%. So load shared by T1 is equal to 30 by 10 divided by 30 by 10 plus 70 by 12 into 100, which is equal to 634 MVA, and rest of the load will be shared by the transformer 2, which is equal to 70 by 12 divided by 30 by 10 plus 70 by 12 into 100, which is equal to 66 MVA. Now how much or how many transformer can be run in parallel condition in a substation? So that is to decided by the short circuit MVA capacity. Now three-phase short circuit current in a bus is equal to full load current in that side of the transformer divided by the percentage impedance. Now for example, two number of 132 by 33 kV 50 MV transformer are running in parallel condition and their percentage impedance are same, that is 12%. So the three-phase short circuit current in the 33 kV bus in case of bus fault will be equal to the full load current in the 33 kV side, which is equal to 874.8 ampere divided by the percentage impedance. Since two number of transformer are running in parallel condition, it will be half of that of the two number of percentage impedance, that is 0.5 into 0.12, which is equal to 14.58 kiloampere for bus fault in the 33 kV bus. Now again, if the four number of transformers are running in parallel condition of the same capacity and same voltage ratio, then the three-phase short circuit current in the 33 kV bus fault will be equal to 874.8 divided by 0.12 divided by 4, which is equal to 29.16 kiloampere. Now, in case of 33 kV breaker, the maximum short circuit capacity is rated as 25 kiloampere for 3 seconds. Since 33 kV circuit breaker short circuit capacity is 25 kiloampere for 3 seconds, and since if the four number of transformers are running in parallel condition, in case of bus fault, this breaker cannot withstand this capacity of the short circuit current. So in that case, there is limitation of the transformer running in parallel condition. So four number of transformer cannot be parallel. So again, the how many number of transformer can be parallel, which is limited by the short circuit capacity of the bus fault. So friends, if you like my video, then do subscribe my channel and press bell button for notification of videos to be uploaded in future. Thank you for watching.